thank you for joining, everybody. So just before we get started, there's a chat where, so please raise any questions that you have in the chat, and we'll certainly try to get to them and steer the conversation that way. So I'm Greg Law. I'm co-founder and CEO at Undo.io, and I'm really thrilled to be joined by such a high caliber panel today with a depth and breadth of knowledge and authority on Java development, and particularly on the subject we're here to talk about, of debugging. So joining us today, we have Angie Jones, who is a Java champion and Senior Director of Developer Relations at Applitools, specializing in test automation strategies and techniques. Angie speaks at conferences all over the world and leads the online learning platform Test Automation University. She is also a master inventor with over 25 patented inventions in the US and in China. Daniel Bryant is the Director of DevRel at Ambassador Labs, with a focus on DevOps tooling, cloud container platforms, and microservices implementations. He is a Java champion and contributes to several open source projects and is a prolific writer and speaker. Josh Long is a Spring developer advocate and a Java champion, author of 6 books, numerous best-selling training videos and podcasts. He's an active open source contributor to Spring Boot, Spring Integration, Spring Cloud, and others. Stefania Chaplin is the solutions architect at Secure Code Warrior and focuses on security throughout the software development lifecycle. She's spoken at many conferences, and she's an active member of OWASP DevSlop and helps coordinate their technical shows. Jonathan Harris is VP of Product at Undo.io, formerly a CTO at Samsung's Tizen, and a former kernel engineer. He's held development and marketing leadership roles at multiple companies at the forefront of mobile innovation, including the really pioneers of that space in Scion and Symbian. And Mary Grygleski is a senior developer advocate at IBM, specializing in reactive Java, open source, cloud, and distributed systems. She's a broad base of experience spanning C and Unix, Java, open source, web, reactive, mobile, and DevOps. And she's the president and executive board member of the Chicago Java Users Group. So thank you all for joining us. I think we're going to have a really interesting conversation today around that topic of debugging, which kind of, like, let's face it, it's not always the sexiest topic, right? It doesn't always get the kind of most interest. And I think that's really strange, because it's so central to the process of software development, right? I mean, I don't know, how many lines of code would you back yourself to write and have it work first time? Like, I don't know, maybe 10, 20, maybe. I mean, maybe you're better than I am, right? But it basically never works first time. And so you got that, what's sometimes referred to as the inner loop debugging. So sometimes by debugging, we think of the outer loop debugging. Customers, found a problem or something late in the development cycle, but it's right from the moment you're keying in the code. And studies show that developers spend typically about 50% of their development time in that process, either inner loop or outer loop debugging. And yet, I think there's a really interesting quote from Brian Kernighan, right? I think many people will have heard this one, but I'll just repeat it. It's a nice quote. He says that debugging is twice as hard as writing the code in the first place. So if you're as clever as you can be when you write it, how will you ever debug it, right? It's a really nice quote. And clearly, what he's mainly saying there is keep it simple. Give yourself kind of margin for error. But if you think that through, kind of follow it through to logical conclusion, I think what it tells us is that debuggability is the limiting factor in software development, right? So whatever your metrics for good is, like whether it's how fast the code runs or how quickly you can produce it or how extensible it is or how small it, like whatever your metric for good is, if you make it twice as debuggable, then it'll get twice as good, right? And yet, right, we hardly talk about it. It's like this elephant in the room, and I don't know, maybe we're sort of collectively embarrassed. I don't know, but you see, there's just countless conferences and books and companies and all this stuff on everything from sort of performance profiling, on languages, on development methodologies, on architectures, monitoring and alerting, and actually, certainly compared to the scale of how significant it is, very, very little on debugging. So we're going to slightly, write that, set that right here, and focus on that debugging stuff in the conversation today. So Mary, I'd like to kick off with you. Is that a premise that you would agree with? And if so, where do you think it comes from?
Sure, I think it's definitely, I think what you said is very true. Like there hasn't been any emphasis on doing debugging. Like you said, everything else is all in the forefront, and somehow debugging is kept in the background, and something that's people just avoid talking about. I don't know what it is, but as I meant, as I said right before when we were discussing, I'm hoping that it can be like a crime scene investigation for software engineering. That's what debugging should be like, and make it more interesting. And like I said, I was working at IT shops, and then there are many occasions in which we need to be figuring out what's going wrong and all that. But actually, it can be so much fun. It's like detective work. It can be painful. It can last a long time. But I think that's also like in a true crime scene too. There's just things that you just can't figure out. We try to piece together all these different evidence. So I feel we in the field, somebody needs to be advocating that debugging can be fun and is also absolutely vital. So I think that's what I feel it should be. So
yeah, Josh, do you want to come in on that?
Yeah, sure. I mean, to add to that, I am somebody who is notoriously good at adding bugs to my software, and so over the span of my career, I've had to learn ways to find ways to remove those bugs. And because last I checked, I couldn't just add it as like extra value to the software and say, here, I added some bugs for you. It's free. They want them out. They want them gone. And I don't know why. So there's all these things that we've done, all these things I've done to support the idea that I want to remove bugs. And so I think a huge amount of what I have focused on, and what all of us are focusing on these days, is to give us the context required to understand what's happening so we can remove those bugs. And ideally, we remove those bugs as early as possible in the process, right? At the very beginning of the pipeline into production, right? So shift left, right? The whole idea that I'm going to move it up earlier into the pipeline. But there's also sort of this productions, ineluctably bugs will creep into production, or sometimes you're using PHP, in which case it is a bug by definition. Either way, we want to make sure that when it's in production, we have ways to find out what's happening. And so there's, metrics, right? You look at metrics as a way of capturing low cardinality data about what's happening in your production system. That gives you ideas about like CPU, how many orders have been processed, how many people have signed up for a new product, whatever. And then you've got tracing, distributed tracing, which gives you high cardinality sort of context around every single individual request. And so you've got that on one end, you've got the observability discussion on the one end, and on the other, you've got the lean manufacturing, Toyota stop the line mentality. Whenever there's a flaw introduced in the system, you stop the line, you make sure you fix it, you root it out, and then you let the process continue. And I just think, if you think that software is about writing the curly brackets in between those two spectrums, those two ends of the continuum, you're missing 99% of it, right? That's the hardest part, is giving yourself that visibility. And I just think we could, if we just said what it is, if we just said that most of what you're going to do when you learn software is just finding ways to not be as confused as you could be otherwise when you get to a bug, because you will have a bug, right? Or 12, or in my case, life would be better.
Yeah, thanks. Angie, what's your take on what you've heard so far?
Did you call me?
Yes, please. Yeah.
Yeah, I think it's really interesting that you brought up the point about we don't really talk about how to make our code in a way that it is debuggable. And I call this really testability, right? It's one of those things that has to be in the forefront of your thought process when you're developing software. It can't be, oh, let me build my feature and then you try to run tests, you know that you can't. When things start failing, you're unable to debug it. All of this plays into that testability aspect. And when I say, make your code testable, I'm not like a TDD purists, if you will, definitely think it's a great process, but I'm not going to shove that down your throat. But there are other ways that you can, ensure that you are building testable code, which then makes it more debuggable by default.
Right. And if it's testable, you can catch them earlier. You can do that shift left thing that Josh was talking about just before. Yeah, Josh?
The other thing is writing testable code is, one of the big reasons I love Spring is because it's a framework that makes it so that you have to write code that is by definition more testable. So you have to write code in terms of objects that have well-defined seams that you can then extract out and test, right? So that's the other reason, is that's another way you can simplify the surface area or reduce the surface area of your bugs, is by eliminating as much of the boilerplate as possible with something like Spring, of course.
Of course. Yeah. Stefania, I think you bring a particular kind of security focus onto things, and obviously there's a real kind of connection between, they're part of flip sides of the same kind. Also, many security, if it's not social engineering, it's usually the exploitation of a bug or something. Yeah, do you want to come in on that?
Yeah, sure. It's interesting because I've heard a few people talking about shift left, which my background's quite a lot in DevSecOps. So I'm like, oh yeah, I know that one. And especially with stuff like testing, or if you flip on the other side, what happens when you don't fix these bugs? It is so much cheaper to fix them, in the IDE, or even, whilst you're doing in CI, then, when you're deploying, when it's in production, when it's been, distributed globally, and you're like, oh no, now we have to do a recall. So it really is about that kind of shift left mindset. And it does start, almost like with the developer, thinking about how you're writing the code, having the testability, using AppSec tools to help, because a lot of the time with bugs, there are many different types, semantic or actual vulnerabilities, etc. But a lot of developers might not know. If you would say, oh, what's an SQL injection? It's like, oh, it means that you have to parameterize your input rather than concatenating the string at the end. Some people might get it, some might not. So I think it's definitely systemic. And the further left you can shift, the better.
But so let me bring in Daniel, because I'd like it, so that we've heard a lot shift left, but there's another thing that you also hear, which seems to me kind of sort of indirect kind of opposition to that, really, of test in production, which is this kind of slightly scary concept. But if you're being really sort of smart about how you do that, it's something that some people swear by. Is that something you've come across a lot, Daniel, and what's your take on it?
Yeah, definitely, Greg. So, and I think they're not mutually exclusive. There's a fantastic blog post I've mentioned many times, Cindy Sudharan, Copy Construct on Twitter, Copy Construct on Medium. She's awesome. I've been lucky enough to meet Cindy several times, and she talks a lot about testing in production is really valuable, particularly when you're building complex adaptive systems, which like many of us are, like with microservices and serverless these days. But it's not an either or. It's like all the stuff everyone's been saying is 100% awesome. Like, love my unit tests, love my integration tests. When I moved to microservices, then there was another like turtle, the old turtles all the way down thing. There's another turtle then when you start putting microservices in the mix, right? And I think a certain level of maturity is often reached before you get the most benefits from testing in production. Like I really say, if you haven't got product market fit, sort of, building good quality code, just getting it out there and shipping experiments is really key. When you get to the likes of your Twitters, your Netflixes, your Googles, or your unicorns, they are doing a lot of testing in production. And I think it's clear value. You don't have to be a unicorn to get this. But I would say, whatever you're doing, keep it simple. But when your system gets to a certain level of complexity, using things like canary releasing, so shameless plug, like we do a lot of stuff in Ambassador with the API gateway, canary releasing, all that kind of good stuff is really, really valuable.
So I used to work at Twitter, and that was my first experience in testing in production. And it's just as Daniel said, it's not an either or. We definitely had to do, our more traditional testing. A lot of times people will look at testing in production as you're throwing this over to the customers, as opposed, how you used to throw something over the wall to QA. Well, okay, let's skip QA and throw it over the wall to the customer. And that's not what this is, right? There was certain areas that were just so complex that you just couldn't test that in-house, right? Not at the magnitude that you wanted to test it at. So these were areas where it made more sense to test it in production. And you don't just throw it over there and then wait for the complaints and the bugs to come in, but you need a sophisticated process with this, so that you're monitoring it, you're observing things that happen before people even get to, maybe they don't even realize it's a bug just yet, or before they get to the help desk phase of it.
Yeah, and so when you're doing that test in production, how do you debug? Which is sort of get it back towards those. So testing obviously is discovering the presence of the bug, but then you know, no good just learning about it, right? We have to do something about it. So what do you do when you've got that, you know, when you have to, your canaries rolled back or something? How do you then fix it?
This is where your observability, your monitoring tools, things like this really come in handy to help you analyze these, you know, what's going on, right? A lot of querying through logs and database transactions and all of this is much more complicated than debugging in your IDE, right?
Yeah, right. Jonathan, let me bring you in. You've got, how can I put this politely? You've got the benefit of lots of experience. You've seen things changing over the years. What, you know, some of this is really new. Some of it probably is sort of trends that come and go. Do you have a sort of perspective on, you know, how things have changed over the years?
Well, certainly testing in production is something you couldn't even contemplate, and still can't if you're actually shipping a physical product, right? Stefania mentioned cost of recall. So if you're actually like shipping something tangible, then you don't have the luxury of test in production. You really do need to be pretty solid. But even if you're not shipping something tangible, as Angie mentioned, it can, you know, poring over logs is a lot harder than just kind of stepping through something in your IDE or looking at a log in your CI environment. So yeah, I guess testing in production is in some way a luxury. I'd like to come back to the idea of shift left and something that Josh mentioned. Josh mentioned the sort of the extreme of shift left being kind of stopping the production line. I think you used that term. That reminded me of something in the DevOps handbook about making, actually kind of making your CI pipeline actually useful. So it's no good just like doing more testing early unless you actually fix the failures. Because if your CI pipeline starts going red, yeah, you can ignore that. I mean, you know, maybe like a test failed, or maybe like next week 5 tests are failing, and then you get to the point very easily, very quickly, and very naturally, because, you know, obviously everybody's got lots of other things to do, where your CI pipeline is effectively useless because it's always red. And if it's not red, it's orange. So there's a real discipline here on actually root causing those failures that are occurring in your pipeline, which is easier said than done, right? Because like, yeah, everybody's got pressures on shipping, and you can always hand wave away a test going, yeah, we don't really need to get to the bottom of that. I'm sure it's not important, and you know, it snowballs. I wonder, do other people have that? Or have seen that happen? Because I certainly have.
There's some nods. I've seen. I won't name the companies, but I've seen a couple of times large, sort of well-known companies decide that it's particularly these flaky tests, right? Something just fails, you know, 1 time in 100 or something, and sort of decide that they can usually write these off as sort of infrastructure problems. It's not actually the test is failing, it's, you know, the network, you know, glitched or whatever. And so they put some code into, we'll just retry the tests when they fail, and if it works on the second run, then, you know, we're good. And it's really hard to come back from there, right? Because you just start, you know, just so much stuff just starts getting checked in, and yeah, the harder, yeah, I've certainly seen that.
think it's a broken Windows thing, Greg. I've definitely seen this where like, for me, it's often the UI tests, and that's not an indication of UI tools. It's just that sometimes it's complicated to test UIs. Get a few flaky tests in the UI, you start putting your sleeps in or whatever, and that ricochets through down the system. You're like, well, someone else has got an ignore on that test. I'll just ignore mine. And then it's like putting it's like the analogy I've heard. It's like thinking your credit card is free money. Do you know what I mean? You just start loading it up, right? And then before you know it, you got all these ignores everywhere and all these like failing tests. And I'm not gonna lie, I think I've probably done that in the past when deadlines, to your point, Jonathan, when deadlines were looming. I was like, right, I'm gonna have to ignore this. Like I'll trade off that tech debt. But it's making that smart choice. Like sometimes looking back in my career, I didn't make the smart choice. I made the easy choice, which is not the right thing. And then you got to come back at some point, and it's 10 times harder to fix it. Do you know what I mean? You really got to pull out all the tools in the toolbox to like locate the problem, triage it, fix it. And I'm sure we've all been there
And
too.
when you've got that kind of background radiation, if you like, of things just randomly failing, it probably isn't your fault, but it might be, and yeah, it gets on. Oh yeah,
I feel seen. All of this is triggering. I'm just very stressed out about it.
Yeah. You always think next week's going to be easier. I'll come back. I'll have more time next week, right?
It is a form of technical debt, though, isn't it? I mean, one kind of thinks of tech debt as being embedded in poor use of frameworks or things like that, but also you can get tech debt in your CI or in your testing infrastructure.
Absolutely. It can be a nightmare. I have like a whole talk on this. That's how bad it is. But we had a time where we were slapping the ignores on the test, and when the business folks went to demo the product to a potential customer, a key feature failed in that demo. And, of course, they come to the engineering team like, what's going on? And it's like, why don't we have a test for this? Why wouldn't we have a test? Oh, we do. We got the ignore tag on it, and it's a hard lesson to learn. And just like you said, Daniel, you have to, you're gonna, this is real life, right? You can't be like, oh, never ignore tests or whatever. But you have to realize the technical debt that you're taking on, and then put a plan in place on how you're going to attack that.
Yeah.
Can you just pay down the technical debt by just not having tests? Wouldn't that?
No.
Oh, darn. Okay. Well, never mind.
Just write bug-free code, right? Easy.
Yeah, just get it right the first time. Should be easy. Come on.
So we got a question in from the audience to the panel. Is anybody familiar with using feature flags? I think companies like Launch Darkly and others are kind of doing some stuff in that. Anyone experienced with that or thoughts on that?
I like it. Oh, sorry.
Go for it, Josh. Go for it.
I was just going to say it follows out really nicely from what we all thought continuous delivery meant circa 2009, right? Like this idea that I'm writing my code to main or the branch formerly known as master. The idea that we're all trunk, there we go. We're all committing to trunk, right? And that work has to be integrated all the time. But that means that it's at any given time, since everybody's doing commits to trunk and that's getting shipped into production, at some point, you're going to have some people that are working on something that would have otherwise been in a branch that needs to be sort of hidden from public access. And so they hide that behind a Boolean or a flag, right? And so now there's a whole discipline around that falls out of that. And there's frameworks that you can use like FF4J, which help you implement that in your code base, just to hide certain pieces of the functionality from production, right? And I think that's and then the other side of that is true as well. So for canary tests, where you have a part of your code that's being tested in a small sampling of your audience, I mean, that's super useful, right? I like that, I guess is what I'm trying to say.
Yeah, it was really helpful when we did the testing in production, right? To be able to put these feature flags up so that you're not rolling this out to all of your users worldwide, but you can, kind of hide it. It allowed us to be able to test better. If there were any issues, it wouldn't affect as many people.
But in effect, that's kind of like a form of canary deployment without actually the canary, because you're kind of exposing this to a subset. I think a lot of the downside of feature flags is if you actually don't get rid of them. So if you allow them to kind of proliferate, and now you have no idea what's going on, and because like you've got 15 feature flags, and which ones are active, and how do they interact with each other. So like if you view it as a form of canary deployment, let's try this one thing out, see if it works, and then kind of take away the feature flag, and now that is part of our trunk. Then that really works well. But if you let them lie around, I'm reminded. Greg reminded everybody that I'm perhaps a little older, maybe, but I'm reminded of if-defs. This is the same problem for those people who are familiar with if-defs in C and C++.
Wonder,
Jonathan, oh, go ahead. I was just going to say really quickly, Jonathan, I love what you were saying there. And I was thinking like, yeah, we kind of roll out like new technology or new concepts that are really old concepts with a new name, but but you know, people like yourself can say, look, we did that. Let me show you how it's going to bite you in the butt, you know. So thank you for that. All right,
everything was done by IBM in the 60s, right?
One pattern I was going to chuck in the mix there for this is something called ratchets. So we've seen this. I used to work on Ruby quite a lot, so there's definitely parallels with Java as well. But we used to see like bad ways of doing things, and we'd pattern match on that using a regex or some kind of other clever tool. And we'd basically put a number in the build saying there's 6 of these in our code base. If ever it goes to 7, fail the build. And whenever you removed the bad pattern, the feature flag, the if-def, you would lower the ratchet to 5. Yeah, and then so it's a great way. So I worked on a couple of Ruby code bases, Rails code bases. I love Rails, but it can be abused. And we used to find a bunch of like doing the same functionality a bunch of different ways, and we use these ratchets to get rid of that. But I've also used it for feature flags. We had a lot of feature flags in that code base too, and we were like, here's the pattern match, and if we spot these like and there's more going in, like we fail the build or we alert based on those things. So again, a lot, it sort of comes back to a general theme of understandability, observability, like on many levels, build time, observable time. But the ratchet pattern for me, if you've got sort of bad pattern in your code base, it's to use.
It's like a limit on your credit card for the text.
Yeah, well, yeah. Good analogy. Yes, exactly.
Is it like lint, but for
totally. There's a couple of really good frameworks that totally escape my brain at the moment, but in Ruby I used some, and then there's some Java ones I've definitely bumped into as well.
So we're doing exactly what I sort of had a rant about at the very beginning of this, right? This has got very much into testing, and we're not talking so much about debugging. So let's try and sort of steer us back to that a little bit. Mary, have you come across tools or techniques or things for actually root causing the bugs that you find work particularly well, or maybe some that you actually sort of now no longer do because you think they don't work?
Yeah, so for tools, I think I do have to say, I think maybe because I came from more of a C background and then more used to like command line, like using like GDB, right? GNU debugger, those are like what I first started using more. On the other hand too, because of those kind of more like a, command line kind of thing, it actually forces me to kind of look closer into the code base and knowing the stack trace pretty clearly. But of course, yeah, these days, right, we got like distributed tracing tool like Zipkin or something like that. I think those are, pretty sophisticated in helping. And I find that it's actually the debugging process obviously is getting more and more complicated now that we have, applications that are, very complicated. I mean, what used to be single thread and now is not just concurrency, but we're dealing with distributed systems on multiple, machines across, different areas and crossing all the boundaries. And how do you trace, especially with reactive scenario? I think I saw a nice article by Josh, and it's kind of the asynchronous way, reactive type of debugging is gotten very complicated. So, so I think, that's what
So Zipkin, you cited as one that you found that particularly helpful for those.
Yes, that's right, for a distributed system. So
I'm struck often actually that the sort of notion that we're going to make everything simple by putting it in microservices, and it's like, I thought distributed systems were supposed to be hard.
Yeah. That's
Yeah.
right. Yeah.
Stefania, do you I'm going to turn to you. Do you see something around the sort of the cultural side of this, and you know, how sort of engineering teams, and perhaps if you have, do you have any view on whether it's better to have a separate QA team to an engineering team, or should that be one coherent team? How do you take that?
It's really about, it's like you said, it's kind of cultural, because what you end up with is so many silos, and it's a bit like we were talking about throwing over the fence to production to the customers, or throwing over to QA. I remember like when I was at uni, and we used to talk about yeah, you do your coding and then testing's right at the end. And now, of course, we're talking about testing here, and security's at the end, and kind of QA's somewhere in the middle. And you always find, especially like say with security, you have, you know, developer tribe, you've got, you know, say QA, and then you've got security, and you just have these silos. So it's about ultimately it's about culture transformation. Like if you look at the whole principles of agile, it's not about buying more tools. It's like, oh yeah, we're going to test here, we're going to have like dynamic testing, we're going to do, you know, QA here, we're going to have everything. It's about getting people to speak to each other and not be mean to each other, and solve problems collaboratively. When you stop pointing the finger and start working together, it's like, well, we do work for the same org and we kind of want the same outcomes. That's what I find the key between breaking up these silos and getting the whole system to work smoother.
Yeah. So it's you know, you used an interesting word there, tribe. That's right, which yeah, you could, when you get that kind of dysfunction, yeah, definitely.
Greg, can I just chip in? Oh.
Mm.
Sorry, Josh. Can I just chip in? One thing I like with the tribes, I was chatting to Melissa Benua, who works at mParticle, did a podcast. So hat tip to Melissa on the InfoQ podcast. And she was talking a lot about tribes and specialists. I think like there's no danger if you've got like a security sort of tribe, chapter, whatever, and they consult for the organization, spread all the good knowledge. And I think it comes back to like almost coming full circle of your original question. I think a lot of challenges with debugging is because it's hard to teach really well. Yeah, do you know what I mean? Like I remember when I was taught at university, at college, very trivial, bit of TDD or whatever, and it was more. And I remember like version control was not even mentioned as another aside. And as soon as I went to proper like actual professional software engineering, it's like you don't know what subversion is or whatever it was, CVS at the time. And I think debugging's the same. I learned from my mentors. I got super lucky. My first job, two amazing folks in the Java space. They taught me like proper debugging, and I actually had production incidents, so I was forced like under pressure to learn these things. But I've come to realize teaching folks I mentor is actually really hard. So if you have specialists in your company that can be security specialists, you know, it's like I think now like problem resolution, or we still talk about like chaos engineering, resilience engineering, they're their own disciplines. But I think having people that can teach these skills, whatever they are, problem location, problem fixing, to Mary's point about crime scene, CSI, you need those folks. And teaching is a very different skill than being good at the thing, right? I learned that at university the hard way. So so I think that's like coming full circle, having like to Stefano's point, like having folks that are specialists, as long as they're communicating and sharing their knowledge, it's awesome. They mustn't be like locked away and just, this is my knowledge, I'm not going to share it.
Mary, I know you've looked at some of that, particularly around that kind of cultural aspect of it. I just wanted to bring you in on that.
Yeah, so exactly. I think it resonates very well what Stefania talked about, right? It's like this tribal mentality. And I feel, right, it's interesting too. I mean, as advocates, I now have folks following me or coming to my talks, my Twitch, and so I noticed too, somebody actually spoke with me and said, you know, I don't want to do a QA job testing because, you know, it's not, testing is not the way to do. But I really don't think so. I actually corrected this person. I said, no, you should look at, you know, we're doing development. It's a holistic process. We're trying to build something at the end that needs to be high quality. Everybody is playing a very important role. There's no like you're better or not better, but I have come across, you know, superb like QA folks that just find the bugs that you wouldn't have thought of as developers because we're too focused on some, you know, kind of like figuring out some algorithms. So we wouldn't have thought of all the use cases that can be exercising those code. So, you know, it's kind of like what Daniel was saying too, it just uses a different kinds of, you know, skills that you need to kind of figuring out things. And it's a detective skills. It's skills that is just beyond you going to a daily, you know, going to a university course or something. It's something that, you know, is just, you know, it's basically, we need a cultural kind of shift in kind of recognizing testing, everything else is important. Support, we're contributing to a whole ecosystem. We're contributing to better software, better things that would serve us better. But yeah, so.
You can get a kind of snobbery in the organizations, can't you? Sometimes of, one group thinking they're kind of, superior to the other group of people, and it's easy for that to happen, and it's completely dysfunctional. Yeah.
Picking up on something Daniel. Oh, go ahead, Angie.
I hear people sometimes, say that we shouldn't have specialists and everybody should be generalists because of all the things that we've mentioned today in this last question. And that's always seemed a little bit wrong to me, yeah, we can have our tribes, we can have specialists, you can have people. I think of it like a sports team, right? Everyone plays their position and everyone shares the same goal to win the game, right? And that's how we should play together. Here's where software delivery goes wrong with that. Everyone takes their piece and then passes it on to the next team member without the context of everything that has happened before. And that's where we start getting into issues where if we shifted left more, if we involved everyone early, let's all have the game plan together, let's practice together, let's do all of these things that, teams in other industries do, I think we would be in a much better position, because debugging doesn't have to happen after the software is delivered even, really, I've had QA people sit in design meetings and be able to point out bugs there, you know what I mean? Before any code has ever been written. And I think that's a key part that we're missing in software delivery as a whole.
So that brings us really nicely onto a question we've had in from the audience. Actually, we've gone, we've gone 38 minutes and we haven't mentioned the pandemic yet. And so I think like various klaxons start going off if you go this long. So the question is, how has the pandemic impacted collaboration? Right? And what we're talking here really is about collaboration across those teams. So anyone want to come in on that, Josh?
I wanted to speak briefly to the last point, and then I think it could conceivably speak to this one as well. But I've been noodling over this. You said earlier that we thought microservices were supposed to be easier, and I wanted to just respectfully disagree. I don't think anybody ever thought adding more moving parts would make things easier. The idea was that it would make things faster, right? So it speaks to all these other things that we're talking about, which is you add more moving parts to the system, not because you want more moving parts in the system, but because it allows you to have smaller teams with people that are forced to work with each other, co-located on the same working product. So you have one team where you have synchronization in that small team, as opposed to siloed teams of people. You have feature teams, right? You have teams that are working on fulfillment service, the order service, the product service, as opposed to dev, admin, Q&A, whatever, right? So now you've got people focused on one deliverable. The cost of synchronization is no longer, it's not a matter of like having a meeting that's redundant with different groups of the organization to tell them what you're doing. They're all focused on the same thing. They're all in the same meetings as you. They have the same context as you. They're all involved in the same thing. And so to do that, you have to have smaller teams. You have to break apart your code base into smaller sizes. As a result, you get this velocity. You get the ability to move software into production more readily, more predictably, more consistently. But yes, you add a bunch of moving parts. So now you have to pay down that tech debt. So things like a opinionated cloud platform, a opinionated Spring framework, opinionated, as many opinions as you can get along the way to reduce the number of moving things that you've now introduced into the system, or at least to give you a consistent default. That helps. But also, I just think because of that, because we've got people on the same page, they're all working together, that helps in the pandemic as well. Having microservices is actually a great thing to do in the world of the pandemic, because it forces people to have one communication hub, one central sort of thing. And then you talk about like how big should the number of people on the team be, right? And people think microservices refers to small code bases. It's not. It's the size of the team. It's we talk about 2 pizza box teams or whatever, right? Small teams focused on one thing. I think that becomes even more valuable when you're distributed, when the boundaries are, imagine you're actually in a physical organization in a building, and you've got literal silos, you've got different offices, different groups, different cubicle farms. Well, now you've got that same siloed nature, but now it's spread across the network boundary because you're behind Zooms, So anything you can do to remove that, to do a reverse Conway maneuver, basically, right? To fix that, that's valuable, especially in the pandemic, right?
Yeah.
I add on top as well. I think a lot of things. So definitely regular syncs, like my team, we're doing, sort of more check-ins because you don't get that water cooler kind of chat as well. But making everything self-service, I think that's a really key thing here. Like if I want to understand, like we're seeing a big push in the industry at the moment around service catalogs. So I'm working on some of the stuff. There's Backstage, there's Clutch, there's all these kind of good things out there. And I think understandability is really important. Again, I sort of mentioned that word before, but we're doing a lot of focus on observability, which for me is sort of runtime understandability, but design time understandability is key. And that's why I think these service catalogs are super interesting, because you can add metadata that then as a self-service manner, like if I'm working on the product service and something's going wrong, I can look up what dependencies are on that service, figure out what teams are owning that, and have a chat with them in the Slack channels. So we're working on a lot of that on Ambassador Labs. We realized even before the pandemic, collaboration is really key. But now I think the onus is even more on self-service for developers in particular. There's lots of ops tools out there in the Kubernetes space, like Lens, Octant, all these good things, but there's not many dev-focused things. So I think that's where we're going to see a lot of innovation over the next few years of understandability in all these serverless and microservice systems. And I think debuggability plugs to Angie's point, like directly into that. So if I can understand what's going on here, I'm in a better position to debug it.
Yeah, I mean, it's the first. It's actually, it really is the 99% of the job of debugging, isn't it? Is understanding. Once you know the problem, it's usually sometimes you go, oh no, I need to completely re-architect this piece of code, but that's usually not. So that, and I think, brings quite nicely to another question that we've got in from the audience. So it feels as if we're sinking into a culture of printf debugging by default. So has the proliferation of complex logging and log mining tools like Splunk made us lazy and resigned to kind of preemptive debugging? So are we getting lazy?
I think just on that, it's quite interesting because I come at it from a security angle, and that's a serious vulnerability in terms of debug features enabled. That's a form of information exposure, because if you've got all your logs and you've got debug on, and then you're printing everything and someone malicious gets hold of that, all of a sudden they know a lot about your system. So for me, this is quite an interesting topic about how people handle it, because for the purpose of debugging, it's great, but you just obviously have to make sure that permissions are correct and not everyone can access that, because that can obviously get you in a lot of trouble.
Right. So it might be
laziness.
It might be understandability cuts both ways. It might be someone who you don't want to understand as well. Sorry, Jonathan, you were going to come in there.
I think laziness is perhaps an uncharitable way of looking at this. Perhaps I think there is definitely a tendency that we are kind of falling back to printf debugging, but part of the reason for that is the complexity of systems that are being debugged now. And like, if your only tool is a hammer or printf, then that's what you're going to do. So your consolidated log is, for a lot of people, their best effort at trying to kind of work out, how did we get here, what happened, like what went wrong, because debugging the entire system as a whole in production is actually quite difficult, and there aren't a lot of tools out there to do that. So we're back at kind of poring over logs again. So laziness perhaps is unfair. It's actually, that's the best that a lot of people can do.
I think there's a whole industry now around that, which is, you talk about observability as the ability to monitor a system by its outputs, right? Well, that's printf. That's printf and beyond, right? Everything you do in runtime to aid in the understanding of what's happening is observability, right? And logs are the first form, but I think the least useful out of the box, right? They're like any discussion around observability will eventually elevate to things like metrics and tracing and so on. I didn't even mention logs earlier, because that just feels like your first cut at this kind of thing. There's better tools for this. But yeah, you're right. Yeah, totally.
One thing I'll just chuck in the mix is like, so shameless plug. So I'm working on a tool, open source tool, CNCF tool, telepresence, for putting like your laptop in the cluster and debugging as if you're in, say, a Kubernetes cluster, for example. But I also see the Rookout folks doing live debugging in production, these kind of things. I think there are, what I would say to folks is there are tools out there if you do find yourself trying to do the printfs, and like the anti-pattern I see with Kubernetes, say, is folks are literally changing their code, building a container, pushing it up to a registry, running stuff and seeing what's going on. Please do not do that. Scaffold, I use Scaffold a lot, Josh. Telepresence is the tool I work on. So obviously shameless plug on that one, but it's those things are game changers. Yeah. A Scaffold opens your debug ports automatically. Telepresence hooks you up. There's a bunch of other tools out there as well, but realize that you often have to go spelunking, searching for these tools. Like it's not readily obvious, but a lot of the tools like your IDE debugger, I love IntelliJ, use IntelliJ a lot. You can use it with and VS Code, same thing as plugins, there's connections, these things. So if you are struggling and you find yourself, so someone said to me the other day, I was actually demoing telepresence to them, and they were like, oh, before I saw like these kind of tools, I thought printf and Docker push was fine, but I realized I had too much time on my hands. And I was like, it's a really good point, right? If you can get these tools that minimize that inner build dev loop that you talked about, Greg, particularly if you're container based, if you can cut out building those containers, suddenly this person had 10 times like more time to do actual stuff rather than building containers, pushing up their printfs or whatever. So
Exactly.
recognize if you're microservicing or containering, the new tools out there, check them out.
Yeah, I would wholeheartedly endorse that, of course. Yeah, I mean, on that, one thing I think I've noticed, so we at Undo, we're deploying the live recorder inside the customers, giving people this great way to debug, and still people are using printf a lot, right? And that gets kind of frustrating sometimes. And what I think I've observed is that we're such creatures of habit. And from right when we wrote that first Hello World program, the first time we typed in a program and it didn't do what we wanted, we were doing printf or whatever the equivalent in that language is. And it's kind of, I think for a lot of developers, it's kind of their happy place, and they can do it without having to think too hard, and because thinking is actually quite unpleasant. And the fact that it takes a long time or an unpredictable amount of time, sometimes I think secretly we almost kind of like, and it's like it's sort of a procrastination kind of thing.
I guess maybe there's also a dopamine hit, like, will the printf actually reveal something this time, or do I have to do it again?
Yeah, like that thing where you get unpredictable rewards, right? So this thing where if you train with rats, if they sometimes get a peanut when they push the button, they'll just do it again and again. Yeah, so printf is, we're all rats in one of these experiments, pushing that button, see if we get the peanut this time.
I think it is a system 1, system 2 thing. If folks have bumped into thinking fast and slow, to your point, Greg, I've definitely been like, oh, I just know this. Like my first line of basic I ever wrote was like a print line, right? And then I'm like, even now as Java or Go, like I write all the same thing, right? But I do think it's like switching to system 2. I've got a problem here. What's the problem? What's the best tools going to be to help me fix this problem? But system 2 is hard work, right? It's switching, to your point, it takes energy. I have to think, whereas like we like to be in system 1 as engineers because we're in flow, right? We're just doing our thing. But
and
you have to step out of that.
It's not that irrational in some ways, because you probably only have how much system 2 compute time have you got in the day, right? If you have a good night's sleep, maybe a couple of hours, like at best, I think, if we're realistic. So people kind of, I think, subconsciously we preserve that. But the irony is, if you spend the time getting proficient with these tools, then they become system 1, and then then you get the best of both worlds. But you have to kind of go through that
I have to work.
So yeah, to Mary's analogy, become a good detective.
Sorry, Jonathan.
So with Mary's analogy, you become a good detective, and then you become more efficient rather than a kind of plod.
So CSI rather than relying on being Sherlock Holmes with this kind of supernatural ability just to kind of figure it out.
CSI JVM. We're calling that one today, right?
Yeah.
There's a show in there, Mary, on Twitch, right? CSI JVM.
OMG.
Yeah. Cool. Well, look, we've gone a little bit over the time that we've actually scheduled this for 45 minutes, but I think the conversation's been fantastic. So I'm very happy to go over a little bit. But one last question in from the audience. So, and again, we were just touching on this a bit, but we'll just perhaps give it a little bit more time. So using Mary's CSI crime scene analogy, what would the panel say they use the most to solve their issues? And what would they really like to have as part of their crime scene tool set to make the process faster and easier? So we're going to go around in turn, and everybody and a chance everybody to give kind of closing comments as we wrap up. So I'm just going to go around the screen in order here. So Jonathan, do you want to go first?
Yeah, well, I guess I must declare an interest, but for me, it's the ability to tell how we got here. So, one of the most basic things is I'm looking at a bit of log output or actual output from the program, and like that can't happen. How did that happen? How did we get here? What happened? So the ability to do time travel debug, to be able to actually go back in time, is the thing that is starting to become available, but is not widely used right now and isn't available in all languages and environments.
I'm not going to argue with that one. Josh.
I was just going to say, yeah, the debugger, the time traveling debugger that Undo are working on is fantastic. I wouldn't be here otherwise if I didn't think that. I believe that you're going to need other kinds of things as well, right? You're going to need tracing, you're going to need logs, I guess, and you're going to need metrics and things like that. But yeah, just the ability to actually take an application and watch it crash, to do a replay, it's wonderful. I think more people would be a lot happier if they had that.
So CCTV maybe in the CSI analogy. Daniel, do you want to give us your take?
Yeah, as a perfect lead in, so I haven't shouted out my friends at Honeycomb and Lightstep. Like they're two awesome companies. Like Charity and team at Honeycomb, very much doing that kind of, almost auto Sherlock Holmes, right? At least point you in the right direction of where, like I know Charity talks a lot about her work at Facebook and Scuba that led to the inspiration behind these tools. And Ben Siegelman, team at Lightstep, fantastic work, similar kind of vein, both complementary, I think. But they are saying you've got this complex adaptive system, look here for the problem. And I think that is important now. Year, 2, 5 years time, it's essential. It's going to be essential. So I see myself combining things like the live debugging with the telepresence in the mix, of course, right? But I do think Honeycomb and Lightstep, those kind of tools, observability at runtime is really critical in distributed systems.
Awesome. Thank you.
Is it possible that the bulk of the complexity in software will be around removing the complexity in software? I mean, it seems like in order to do a good job of this, delivering software to production for customers that are happy, we have all these, we've talked so little about the actual writing of the software, and all of this is stuff that just builds on top of the fundamental, like I'm going to write software that does X. That's the easiest part, right? That it's the happy path. That's super easy. Everything else is really hard, right? It's all this other stuff. And I wonder if that's what separates the novice from the experienced, is an appreciation for just how undone it is until you've done all this other stuff.
Yeah. Stefania, what
yeah, so my perspective is a little different. So, don't hate me, but I play a lot around with systems and I try and get environments to work and integrate. So my top tip is mainly on Unix. I use a lot of grep. I'm like, what's going on?
Old school.
What's running? What's not? Let's try and make it work. So that's universal.
That's good. Yeah, well, I think we all use grep a lot, right? It's one of those. Absolutely. Mary, what would you choose?
Well, I think I agree totally what everybody has said is we a combination, but I think as a developer myself, right, I come from more of an enterprise kind of situation. So it's definitely in my code, I want to put in all the logger statement and then enabling them at different, levels of debugging. So that's still, I think the logging part is very essential. And then it will be combining, right, with the new tools. And in fact, I never knew about Honeycomb. And so thank you, Daniel. I learned about it. So I started looking. It's looks pretty cool. So like some of these newer kind of observability type of tools, yeah, I'm going to start looking into that too. And like I said, distributed tracing like Zipkin or something, I would be looking, using those too. So it's really a combination of different ways and means to kind of like debug to play detective on any kind of issue. I think that's the best. So.
There's also Sentry, which I kind of find interesting. Sentry is basically you add it to the code base and it'll automatically capture exceptions or errors. So it'll surface that, it'll create an issue for you, create a breadcrumb trail. So basically we look at logs to find the errors, but what if our code could just tell us here's the errors directly and just put it to send it to our inbox and then give us the ability to act treat it like a Jira ticket or whatever, right?
Pretty cool, yeah. And Angie, last word to you. We're just
yeah. So I thought I was doing pretty good because I graduated from the system that out that println statements, and I use my IDE debugger a lot, right? And I find a lot of people don't know how to use this effectively, so that's my go-to. For more advanced debugging, I'll use something like Splunk, but I've definitely taken notes on the ones that were mentioned by you gurus. So I'm going to level up my debugging game.
And with your help, I've leveled up my testing games. I think we're
good.
Yeah. Well, look, everyone, that was really, I had high hopes for this conversation, and they were exceeded. It's been really interesting. Thank you very much. So it just, I was going to take a note. So I was going to do a recap, but I think we're just out of time. So we'll just have to all go and watch the video to get the recap. So it just remains for me to thank Daniel Bryant, Stefania Chaplin, Mary Grygleski, Angie Jones, Josh Long, and Jonathan Harris. Thank you very much, all of you.